welcome back. Today we are covering lesson 88 and talking about solving abstract equations. So an abstract equation can sometimes also be called a literal equation. So although this lesson mostly uses the term abstract equation, you may also see these called literal equations. And the characteristic of abstract or literal equations is that there are two or more variables within the equation. So we've already seen equations with multiple variables in them. We're just giving them an official name. And when we are solving abstract or literal equations, what we are actually doing is solving the equation in terms of other variables. So what that means is, although we may be solving an equation that has both x and y, we might be solving it for y, but it's going to be in terms of x, which means the equation is going to have x inside of it. And you have already been doing this for some equations. For example, if you are given a linear equation that is not in slope-intercept form, you can put that equation into slope-intercept form by solving for y. And it's in terms of x because the equation still has x in it. So you've actually already been doing this. Your textbook is a little bit sneaky in the fact that it just goes ahead and has you doing some of this work without knowing exactly what it's called. But when we're solving these equations, the main thing to remember is that your answer is not going to be just a number. Your answer is going to be basically what looks like an equation with other variables in it. The main thing that we still want to remember is that anytime we are solving for any variable, we get that variable by itself with no other occurrences of it on one side of the equal sign, and on the other side of the equal sign is everything else. And literal equations or abstract equations come up a lot in formulas for business and science. So, for example, the formula to convert between temperature measurement systems between Fahrenheit and Celsius is this. Temperature in Fahrenheit is equal to 9/5 times the equivalent Fahrenheit and temperature in Celsius plus 32. So this is, again, temperature. And so this equation has one equation with two variables in it. And we could solve this equation for C in order to set it up as Celsius is equal to something with Fahrenheit as the input. So sometimes when we're dealing with science or business applications, we will find ourselves switching between variables like that so that we can use the equation more easily. Physics has a lot of these types of equations. So this equation, you don't need to memorize this, but just to show you as an example. So the height, we can calculate the height of a free falling object at a point in time. And that height is equal to 1/2 times the gravity times the time squared plus the initial velocity times time plus the initial height. So again, you don't have to memorize these equations, so don't get hung up on that. I just want to show you a couple applications where we have these abstract equations. And chances are, if you've taken chemistry or physics or economics or some other class like that, you have seen equations like this, where they have multiple inputs, multiple variables, if you will, and those all go into calculating yet another variable. So let's do an example. We want to solve this equation for S. And this is the equation that we're given. V is equal to 1 1/3 s squared times h. So what's the most important thing for solving these equations is to remember what it is that you're solving for and not sometimes get lost in the weeds and accidentally solve for something else. So see that I have three variables in this equation. I have h, I have s, and I have v. And right now it's set up to be solved for v, but I want to now solve it for s. And sometimes I prefer to think of it less as solving and more as rearranging it. So whichever mindset is easier for you. But I want to get the s by itself. So to start out with that, I'm going to multiply both sides by 3 so that I can eliminate that 1/3 first. So I'll have 3 times v is equal to s squared times h. Now I need to move that h. I know there's an s squared, but remember when we're solving, we work our order of operations backwards, or in a more general sense, I think of it as working from the outside in. So the next thing I need to get rid of is that h. So I'm going to divide this side by h, divide the other side by h. So now I have 3 times v over h is equal to s squared. And now the squared is the only thing I have left to deal with. And to get rid of a squared when we're solving something, we need to take the square root of both sides. So then I'm left with s is equal to plus or minus the square root of 3 times v over h. And notice I had to include that plus or minus because I'm taking the square root of something that was already existing. So I don't know whether it's positive or negative, and so we're going to have either the plus or minus option. And so this new equation is my answer. So remember, it's not going to be a number. We're not trying to eliminate any other variables. It's supposed to have other variables in the answer. So if you find yourself with just a number, you should go back and check your work because your answer should have the rest of the variables in it. And that's it for this lesson, and I'll see you next time.